Hello everyone. So till now what we were discussing was system of linear equations. Now in this lecture we are going to discuss about system of nonlinear equations. Okay. So let us say we have okay, before I start, I think the content that I'll be discussing in this particular lecture, some of the content we have already discussed in the lecture of finding roots. Okay. So when you talk about the lecture of finding roots, what we had a single equation, okay, and we had to find out the root of that particular equation, okay, and that equation was either linear or non-linear, but mostly if you see the problems that we have considered was all non-linear. Okay, so to find out the root, the methods that we discussed was bracketing method, but apart from all those methods, I think we discussed about open method that is known as Newton-Raphson method, okay, and secant method as well. So in this lecture, what we are going to discuss is we are going to find out a solution of a system of nonlinear equation. Let us say this is your first nonlinear equation, this is your second nonlinear equation, and this is your nth nonlinear equation. Now to solve system of nonlinear equation, there are a lot of methods, okay, but the method that actually we are going to discuss in this particular course is just going to be Newton-Raphson method. There are a lot of methods, but since this is an undergraduate class, we are just going to discuss Newton-Raphson method. So we are going to make this Newton-Raphson method. We have already discussed Newton-Raphson method, but it was just for a single equation with one unknown. Okay, so what we are going to do here is we are going to make this Newton-Raphson method adapted to multiple equations and multiple unknown. And mostly since we will be solving the problem by hand, so we'll just be taking the problem with three equations and three unknowns. So if you recall, Newton-Raphson method is xi minus f of x upon f dash of x. Okay, so this is your Newton-Raphson method. Also, we discussed about shortcoming of Newton-Raphson method, that is we have to find out the derivative, and in real life this derivative is often very complicated. But anyways, we are not going to discuss the disadvantages at this point. So this is the Newton-Raphson method for single unknown. So what we are going to do, we are going to make this equation adapted to for the problem with multiple unknowns. Okay, so this time I'll reserve I. I'll not use I. In Newton-Raphson method we used I. I was for iteration. Okay, but I'll reserve I for something else. I will be for my variable. That is going to be x1, x2, x3. Okay, so I is nothing but it's reserved for variable. So x1 is nothing but x, x2 y, and z when you just talk about three variables. Okay, anyways, so let us talk about how you are going to adapt this equation to a system of equation. So since we are dealing with system of equation, we'll be using vectors. So again, the sign convention that we'll be using, I'll be using a dash below a variable to represent that it is a vector, and I'm going to use a tilde below a variable to denote that it's a matrix. So this is going to be x, so vector of x for current iteration, okay, is equal to x, vector x from previous iteration. So x, when I say capital X, so capital X is nothing but x1, x2, x3, xn, okay, minus of, now if you see these are, there is a derivative, but now we have to take system, we have to take a lot of derivatives, okay, and it's going to be for a system. So what we do is we replace it by a matrix, special kind of matrix that is known as Jacobian matrix, and we take the inverse. Okay, this is going to be Jacobian matrix for variables for k minus 1 into f. Okay, f is going to be vector f k minus 1. So this is going to be your Newton-Raphson for system of equations. So when you talk about f, vector f, it's going to be f1, x1, x2, x3, xn. So this is going to be for n equations. So f, vector f, x. Okay. And when you talk about your x is going to be this. And when you talk about your Jacobi, it's going to be differentiation. It's going to be a matrix. So this is known as your Jacobian matrix. So this is how it's going to be. Okay. Now since we'll be solving the problem just for 3 variables by hand, if you want to solve for more variables, more than 3 variables, I don't think you will be able to solve it by hand. You have to use your softwares. Okay, you have to develop a code for it. So just for 3 variables, I can write down. Okay, this is going to be. So if you remember here, we were for iterative methods for solving system of linear equation, we were using k plus 1 and this is k. Okay, it doesn't matter. Okay, if you want, you can use k plus 1, but I think this is better. Okay, so and this is going to be, okay, let us just write down for 3 variables here. So the equation is going to be, so this is for 3 variables and this is what you are going to use. Okay, so basically what this says is the values of x. So you have to, so you know, and for Newton-Raphson method for single variable, you used some initial value. Okay, initialization, you used some initial value. So you here also you have to use 3 initial values. So you are going to take that value and then find out xik, okay, using the previous values. Also you are going to find out this Jacobian and all this thing. Okay, and then you are going to find out the value for current iteration. Then for the next iteration, that will become your previous values for previous iteration, values of previous iteration. Again you are going to solve this iteratively.